Hey, welcome back. This is the final exam review for trigonometry, and you'll be able to use the formula sheets from test 2 and test 3. So new sheet from test 2 and test 3. But on the first page, you're going to have to list a whole bunch of identities and stuff. So let me first talk about that. So on the first page, you have to do basically a memory dump. So in my opinion, you know, the major part of trig is just a lot of memorization. So anyways, first page, you have to first have that chart with all the reference angles on it. So what do we have? Theta, and then what did I usually put it at sine first? I don't remember. Sine theta, and then cosine theta, and then tan theta. Okay, so we go from 0 to pi over 6, and then pi over 4, and then pi over 3, and then pi over 2. So the way you fill out the chart is pretty easy. You just go 0, and then we have some fractions, and then 1. And then it's kind of reversed for cosine. Across the numerator, it's 1, 2, 3. In the denominator, it's always 2. You're taking square roots of the numerator, so root 2, root 3. And then reverse it for cosine. 1, 2, 3. And then you can finally take the ratios to get tan, because tan is equal to sine over cosine, right? So 0 over 1 is 0. 1 half all over root 3 over 2 is the same as 1 over root 3. If you'd rather, you can write root 3 over 3. Root 2 over 2 over root 2 over 2 is 1. Root 3 over 2 over 1 over 2 is root 3. And then 1 over 0 is undefined. Okay? So we need the chart. Secondly, and I'll have this all listed, what you need to write down. You need the reciprocal, quotient, and the right angle definitions for the 6 trig functions, or right triangle definitions. So, you know, sine theta is equal to opposite over hypotenuse, which is also equal to 1 over cosecant theta. Cosecant theta is equal to hypotenuse over opposite, which is also equal to 1 over sine. Cosine of theta is equal to adjacent over hypotenuse, which of course is just going to be 1 over secant. Sure that looks like an A. Then secant theta is of course hypotenuse over adjacent, which will be 1 over cosine. What else? We got the tan theta. Tan theta is opposite over adjacent, which is the same as 1 over cotan. But we also have the quotient identity for tangent, which is sine theta over cosine theta. Cotan theta then is just take the reciprocals of all that, A over O, 1 over tan, and then cosine over sine. Okay. We need the even odd identities. So the only one that's even is cosine and secant. So I should say one. The only two that are even will be cosine. So cosine of negative x will just give you cosine of x. And that'll be the same deal for secant. The rest are odd. Right, so sine of negative x is negative sine x. Cosecant of negative x is negative cosecant x. And then tan of negative x is negative tan x. Does that look like negative in front? And then cotan of negative x is negative cotan x. Okay. Okay, so even odd identities, Pythagorean identities. So Pythagoreans. The main one, of course, cosine squared plus sine squared is equal to 1. And then if you divide everything by cosine squared, you'll get 1 plus tan squared equals secant squared. And then if you divide everything by sine squared, you'll get cotan squared plus 1 equals cosecant squared. Okay. Then the last set, there were these kind of random identities, the identity for sine 2x, the identity for sine squared x, and the identity for cosine squared x. So I just picked these out because I know in certain sections when I teach Calc 2, those three identities are like the most important identities in that whole sort of spiel of identities they throw at you in chapter 5. Okay, so these turn out to be useful later on in life if you keep taking math, is kind of what I'm getting at. So anyway, sine 2x is the 2 sine x cosine x. Sine squared x is going to be 1 minus cosine 2x all over 2. And on the second test, we also had the sine equals plus or minus square. On the final exam, you're not going to need that plus or minus square root version. The last identity that you need to list is the cosine squared equals 1 plus cosine 2x over 2. And then there's going to be some other things that you kind of need to know sprinkled throughout the test that you might want to just write down if you got a little bit of room. One thing is the standing room only formula. That gives you arc length. Remember, theta has to be in terms of radians, though. So what are some other things? The range of sine inverse and cosine inverse and tan inverse, sometimes you're called upon to do that. So the outputs of cosine inverse will be from 0 to pi, and then the outputs of sine inverse will be from negative pi over 2 to the pi over 2, and then the outputs of tan inverse are just like sine inverse basically, except you can't include the endpoints, negative pi over 2 to pi over 2. And that comes up at the end of, I think that was it in chapter 5 or chapter 6? I think it was in chapter 5. No, actually it's in chapter 4, I think, at the end of chapter 4. But I'll go over those kinds of problems as we get there. And you need to know little things that I kind of take for granted, like what is the dot product? How do I find the magnitude of a vector? Those things as well. But anyways, let's dive in here. And what I'm doing here is I'm just giving you kind of an example of a couple of problems from each section. And any problem I do is kind of fair game on the test. There's no way I'll put this many questions on the final, though. I'm probably thinking 25 questions in about that realm. But any of these types of questions are fair game. So anyways, 4.1, just an introduction to measurement of angles. So you have degrees and radians. First types of problems you would have seen were converting from one type to the other. So 135 degrees, I want to convert it to radians. So you have to multiply by this conversion factor. There are 180 degrees in pi radians. Right, so if we multiply this together, the degrees will cancel out, and you're just left with radians. If you go to your calculator here and divide top and bottom, you'll end up with 3/4 or 3 pi over 4. Okay, you have to be able to go in the other direction as well. So 27, convert to degrees, so negative 3 pi over 1. This time we have to multiply by 180 over pi. So the radian part will cancel out and left in degrees. So negative 3 times 180 will leave you with negative 540 degrees. So we should all know how to do conversions back and forth without too much work. One formula that comes up kind of periodically would be this standing room only formula, right? So this computes the length of a arc of a circle. For example, the walking distance from walking on the circle from this point here to this point here. If you know the angle theta in terms of radians and you also know the radius, you can figure out that walking distance. Okay, so one warning, you have to make sure theta is in terms of radians. So in 73, they give you the radius is 8 feet. So the radius, is 8 feet. And then they tell you theta is 225. So they're trying to trick you here. You need to convert the 225 degrees into radians. So, you know, there's 180 degrees and pi radians. And if you do that in your calculator, you get 5 pi over 4. So the arc length then will be 8 times 5 pi over 4. 4 goes into 8 2 times, so you'll end up with 10 pi, and this answer is in feet. All right, so just a simple application, but that formula is important later on in other settings if you kept taking math. Anyways, let's say 4.2. So we're looking at problems like 5 to 17, 39 to 45. So, and we start getting our feet wet with computing cosine of particular angles. And later on, we get the method is kind of like identify the reference angle and then look at which quadrant your given angle is in, and that tells you the answer. So, but you could apply those methods here, right? So, for example, cosine of 5 pi over 6. So the reference angle would be pi over 6. So you know cosine of pi over 6 is root 3 over 2. You just have to determine if it's positive or negative. And to figure that out, you just go to your unit circle here, find where 5 pi over 6 is. It's over here. Cosine is negative in that quadrant. So cosine is kind of associated with the x value. So the x value would be negative in that quadrant. So this has to be a negative answer. Okay, let's just look at a whole bunch of these. I'll be putting a bunch on the test. Please, please, please do not use the calculator for these questions. Anyways, I should see some work, right? I should see your little drawing with so I want to see that, yeah. For credit, if you can't just write the answer, you have to draw kind of where that angle is, which quadrant is that angle in, and then make your conclusion based off of that. So I need to see this picture for full credit. I need to see some sort of work. Okay, you can't just put it in your calculator. All right, so anyways, we have cosecant of 7 pi over 6. Cosecant is like sine, right? It's 1 over sine. The reference angle is pi over 6. So for pi over 6, sine would have been 1/2. So cosecant is actually 2. And I have to figure out if it's negative or positive. So 7 pi over 6 is in the third quadrant. There's my little picture. You can even impress me with some Roman numerals. Okay, so I'm in the third quadrant. Sine is negative in that quadrant, so your answer should be negative. Okay, let's get another 12. Secant of 11 pi over 6. So, secant is 1 over cosine. The reference angle is pi over 6, so this is a root 3 over 2. Whereas 11 pi over 6 is 1 less than 2 pi, right? So it would be in the fourth quadrant, and therefore it's positive. So just, oops, and it should be upside down, right? Because that would have been cosine. We want secant. So 1 over root 3 over 2. So it would be 2 all over root 3. Or if you would rather, 2 root 3 over 3. Either answer is fine on the test. So if you'd rather just leave it without a rationalized denominator, that's quite all right. Let's look at some more. 17. 17. We have the secant of 3 pi over 2. So where is 3 pi over 2? That's just down here. So rotating around to there. Secant is what? Oh, it's 1 over cosine, right? Cosine of 3 pi over 2 is 0. So you'd have like 1 over 0, which is undefined. So this thing won't work. This is undefined. So you just write undefined. Let's look at 18. tan of 3 pi over 2. And this has the same issue, right? Because tan is sine over cosine. So you'd have like sine would be -1 of 3 pi over 2, and then cosine of 3 pi over 2 would be 0. So again, if you can't divide by 0, it's just undefined. We don't do that in math. Let's look at 41, and we have the sine of -9 pi over 4. Okay. So on our plot here, -9 pi over 4 is, well, here's -8 pi over 4. That's -2 pi. And then you just go one more place around. So you're going to end up in that fourth quadrant. Sine is negative there. The reference angle is pi over 4, so it would be √2 over 2. Okay. So when you're doing these problems where you're just evaluating and you're supposed to not be using your calculator, you got to show me those little pictures. Okay, show me some work. Otherwise, I'm not going to give you credit. Okay, 4.3. 4.3, I think we really started connecting the right triangle to these trig functions. I like problems like 5 to, where is it, 4.3? No, 1 to 7. So there's some kind of like puzzle type questions in 1 to 7. And then also 29 to 33. Okay, so what they're going to do in 1 to 7 is give you kind of some information. You got to retrieve the 6 trig functions of a particular angle theta. Okay, so here's my angle theta. Here's one side is 26, the other side is 10. And they want you to find sine of theta, cosine of theta, etc. Secant theta, secant theta, cotan theta. Okay, in order to figure this out, you're going to have to use Pythagorean Theorem. This is a right triangle. Okay, so if we call this leg B, I'll be looking at 10 squared plus B squared equals 26 squared. B squared will be then 26 squared minus 10 squared, and then take the square root on both sides with your calculator. B is the square root of 26 squared minus 10 squared, which turns out to be a nice question, nice answer. Or is it 24? Turns out to be really easy. Okay. So this side will be 24. All right, so sine of theta is, now you have to remember opposite over hypotenuse, adjacent over hypotenuse, all that jazz. So sine is opposite over hypotenuse, same as 5/13. And then you automatically have cosecant, right? Just take the reciprocal. Cosine is adjacent over hypotenuse. And you don't even have to reduce. I'm just doing that because that's what I do as a teacher. 13 over 12 for secant. Tan is opposite over adjacent. This would be 5 over 12 or 12 over 5. Okay. Let's look at like 33. So again, this is another problem. They'll give you some information. It's not quite like the last one, but let's take a look anyways. So we have 16, and we want to figure out C. So they give you some information. You have to figure out this unknown side. And they tell you this angle is 23 degrees. So you can use your trig functions to figure out C. So basically tan of 20, well, no, not tan. We want opposite over hypotenuse, right? To get all the unknown, all the information in the unknown together in one equation. So what would be opposite over hypotenuse? That's sine, right? So sine of 23 is equal to opposite over hypotenuse. And then we can multiply both sides by c, divide both sides by sine 23. You get c equals 16 over sine 23. They want you, in the book it says to simplify your answer to the nearest 33, 4.3. Well, it tells you in the book how to simplify. It turns out to be 41. Okay. Okay, 4.4, we extend this kind of idea of right triangles to work in any quadrant. Okay, so 4.4, I'm thinking of questions similar to 1 to 17 and then 47 to 61. So you know, when you go to study, I'm going to do here in my notes, I'm going to do number 27, I think, and then a bunch of other ones. When you go to study, you know, look at 26, look at 25, those kind of questions. And if you do that and you do all the questions that are kind of similar, you'll do really good on the final. Okay, so I'm not going to be throwing any curveballs at you really at this level. Okay. So anyways, they tell you some information, and then you got to figure out the 6 trig functions based off of it. So I got sine of theta, cosine theta, tan theta, cosecant theta, secant theta, and then finally cotan theta. Okay. All right, so the second portion tells me I'm in the 4th quadrant, okay, quad 4. And you're going to put a little triangle on that 4th quadrant, right? So you just draw a right triangle here. And then the cosine of this angle theta, they're telling you then that adjacent over hypotenuse. So the adjacent side is 8 and the hypotenuse side is 17. And then you just use the Pythagorean theorem to get to that 3rd side. And then for all the trig functions, you just use that triangle to determine their values. Okay, so I need the Pythagorean theorem first. So I'll have 17 squared equals 8 squared plus b squared. I want to solve for b. So b will end up equaling the square root of 17 squared minus 8 squared, which will end up being, and it's really plus or minus. And because this side is going down in the 4th quadrant, it has to be a negative value. If you put that in your calculator, I'll put negative 15. Okay, so this side will be negative 15. Because the coordinate of this point is basically positive 8 and then down 15. Right? Right. Then you can just use that triangle to figure out the other 5 trig functions. So we know this one is 8/17. This will be 17/8. Sine of that angle, opposite, negative 15 over hypotenuse, 17. So cosecant, negative 17 over 15. Then tan of that is opposite over adjacent. And so cotan is negative 8 over 15. Okay. There's also this section. There's a bunch of more of those problems where you're figuring out the sine of particular angles, cosine of particular angles without a calculator. Okay. So again, when you see these questions, you should be drawing a little xy plane and putting the angle in the appropriate quadrant. So 2 pi over 3. 1 pi over 2, 2 pi over 3 is in quadrant 2. So sine will be positive. The reference angle is pi over 3, so it's going to be root 3 over 2. Let's look at 69. So we have cosecant of 7 pi over 6. Cosecant is 1 over sine. 7 pi over 6 is 1 more than 6 pi over 6, so it's in the 3rd quadrant. Sine is negative in the 3rd quadrant, so this will be negative. Reference angle pi over 6, sine of pi over 6 is 1/2, cosecant then is 2, so that being negative 2. Let's look at one more. Cotan of 19 pi over 6. So 12 pi over 6 is 2 pi, that's right here. And then 18 pi over 6 is 3 pi, that's right here. And then we need to go one more to 19 pi over 6. So I'll be in the 3rd quadrant. The reference angle is pi over 6. So in that case, it would be usually 1 over root 3. But because it's cotan, it will be root 3 over 1. And then cotan is positive in that quadrant. So it would just be root 3. Okay, 4.5, we get into graphing these objects, and so I would expect you to be able to graph cosine or sine versions in all of their glory with phase shifts, amplitude, and unusual periods. So I'm looking at problems like 1 to 51. Let me do a sine and then a cosine. So 25, I have y equals negative 2 sine of 2x plus pi over 2. Okay. All right, so first start with the amplitude. The amplitude is the absolute value of whatever's in front of sine. So 2. Secondly, we need the period and the phase shift. I'll abbreviate phase shift as PS. So to get this information, you wedge the insides of the sine function in between 0 and 2 pi. Right? So you have 2x plus pi over 2, and you wedge that in between 0 and 2 pi. Your next step is to isolate the x. Okay, so first you're going to minus pi over 2 to all three sides. And so I can easily see the period. I'm not going to add the 2 pi and the pi over 2 together. Right? So I just have 2x less than or equal to 2 pi minus pi over 2. Okay. Then I need to multiply everything by 1/2 to get x all by itself. And I'll be able to clearly read off the period and the phase shift. So the phase shift is negative pi over 4. The period will be pi. Okay, so the period is basically, if you do it this way, it's going to be this thing here. Okay? Otherwise, you have to take pi minus, you take this right side and just subtract the left side. They give you the same answer. It'll be pi minus pi over 4 minus negative pi over 4, which will be pi. So anyways, you have to identify the period as pi. The phase shift is just this number then on the left. Okay. So the phase shift will be negative pi over 4. Finally, your tick marks are your, maybe we called them key points back in the day. So what are you doing here? You're dividing the period by 4. So that you take the period and divide or multiply by 1 over 4. And you get pi over 4. Okay. So you're going to start where the phase shift is and then use the pi over 4s to move to the next key point. Right? So I'm going to start at negative pi over 4 and then use the key points to move. So negative pi over 4, and then the next one will be at 0, and then positive pi over 4, and then 2 pi over 4, and then 3 pi over 4. Okay, for one period. Again, the amplitude is 2. Okay. You'd be a little careful. There is a flip, right? If you put that negative in front, it will rotate the graph about the x-axis. So usually, normally it would kind of go for sine functions. It would go like this, but because of that negative, it's going to flip it upside down. Okay, so I'll draw my end answer here in red or black. Actually, it's going to go down and then back up and then down like that. There's one period. Okay. Okay. Let's do a cosine version then. So number 39, we have y equals negative 4 cosine of 1/2 x. Again, first start the amplitude. The amplitude is absolute value negative 4. Okay. The period and phase shift, there is no phase shift this time. Phase shift will be 0. But anyways, you take the insides of your cosine right here and wedge it again in between 0 and 2 pi. Multiply everything by 2. And the phase shift is 0. And the period is 4 pi. Okay. So for your key points, then you just take the 4 pi and divide it by 4. So you're going to be going by pi. Okay. So let's just get one period. Amplitude of 4, 1, 2, 3, 4, 1, 2, 3, 4, and I'm going by pi's on the x-axis. Okay, so cosine starts up at positive 4, but there's a rotation. So normally it would look like this. I'll do it in blue. But because that negative is sitting in front, it's going to rotate that about the x-axis. I'll do my final answer in black. So it'll look like this. Okay. And then 1 period is all they ask for in the book, and I take my questions directly from the book. Okay. Okay, the next section then was all the other graphs. So 4.6 included tan, cotan, cosecant, and secant. I'm not going to beat you over the head with this stuff. I'm just going to expect you to be able to do a tangent. So number 7. And in general, the types of problems in 4.6, I'll be thinking of 5 to 11. Okay, I'll give you problem sets for everything. 4.4, 3, yeah, we're good. Okay, so 4.6, I'm just going to focus in on the tan guys. And the main part you have to remember for this is this kind of setup right here, where you're figuring out the period and the phase shift. Instead of going from 0 to 2 pi, you're going from negative pi over 2 to pi over 2. And it's basically just where cosine is equal to 0. Because where cosine is equal to 0, you're basically going to be dividing by 0, so you'll have a vertical asymptote, right? So first note, and we didn't really they didn't have a name for it in the book, like amplitude, but I just think of it as an amplitude value, the thing in front, the a value is 1/2. In our setting with tangents, it's going to kind of tell you these quarter points. So normally your graph would look like this. And the a value kind of tells you the heights of those 2 points there. Okay. Normally they would be at 1 on the y-axis or -1. The amplitude now, so if you multiply it by 1/2, those points will be at -1/2 and 1/2 on the y-axis. Okay. Okay. Secondly, then the period and the phase shift. In this problem, there is no phase shift. I don't think any of the problems in the set that I'm giving you have a phase shift. But you're taking negative pi over 2, and you're wedging the kind of insides of the tan function in between negative pi over 2 and pi over 2. Okay. So again, the reason why we do that is because there's asymptotes at negative pi over 2 and pi over 2. And there's asymptotes there because tan is really equal to sine over cosine, and cosine is equal to 0 at pi over 2 and negative pi over 2. Okay? So there'll be division by 0. In other words, there'll be asymptotes there. To get the period in this problem, these kind of problems, you're taking the endpoints and subtracting them. There's no way around it. You kind of have to do it that way. Okay. I mean, technically, you could always do it back here. It's just always kind of silly because if you went 4 pi minus 0, you would just get 4 pi for the period. I mean, you could always do this the same way, but sometimes just kind of silly. Anyways, what do we have for a period? Then it would be pi over 2 minus negative pi over 2. So that would be pi over 2 plus pi over 2, which is 2 pi over 2, which is pi. Okay. So for our basically our key points, we'll start at the, and I forgot to divide by 2, so this would be negative pi over 4. So that's going to screw this up as well. Sorry. Let me just put it below. So I forgot to isolate the x. So I have to divide everything by 1/2, or multiply everything by 1/2. You get negative pi over 4 less than x less than pi over 4. So the period then, it would be pi over 4 minus negative pi over 4. Be pi over 4 plus pi over 4, which is 2 pi over 4, which is pi over 2. Okay. So for the key points, you're starting at this on the left there, on that inequality. So you're starting at negative pi over 4. And then you're moving by 1/4 of the period. Okay, so you'll add in pi all over 2 times 1/4. Okay, so it's always going to go negative pi over 4, and then you move over by pi over 8 to get to the next point. And what I generally would do is find a common denominator to make it a little more easy to do the computations. Okay. So you're going to start at negative 2 pi over 8 and then move by pi over 8ths until you get to the other asymptote. Okay? In the book, they want 2 periods for this work. Okay? So I'm going to start at negative pi over 4, but I'm really going to put 2 pi over 8. So negative 2 pi over 8 is our first asymptote. Okay, and then we have kind of a quote-unquote amplitude of 1/2. So this would be negative 1. So 1/2 would be here, and that would give you these kind of weird quarter points. Then it goes through 0, and then we'll have another quarter point. So this would be, the first one is at negative 1 pi over 8, and then 0, and then this is at pi over 8, because you just keep on moving over by pi over 8s. And then we have a 2 pi over 8, which is where the other asymptote is, at pi over 4. And then you could keep moving, 3 pi over 8 for another one of the quarter points, which I'm going to have to put right over top that number. 4 pi over 8. And finally 5 pi over 8. And then there's another asymptote at 6 pi over 8. Okay. We just want 2 periods, so that'll do the job. And then draw these things. So this first one should be kind of concave down. And then the second one is concave up. It's kind of bowl shape upwards. Okay. And then the same deal here. Kind of goes like this, and then goes like this. Okay. You should put little arrowheads on these. They go on forever and ever. They don't ever hit the asymptotes. Okay. Okay. 4.7, then we finally get back into this inverse function thing. I was talking a little bit. You kind of have to have these ideas memorized. For cosine inverse of x, the output will be from 0 to pi. And then for sine inverse of x, the output will be from negative pi over 2 to pi over 2. And then tan inverse, also negative pi over 2 to the pi over 2, but not including those endpoints. Right. Okay. So let's take a look at this in action. And again, you should be drawing little pictures with these when you figure them out. 3 over 2. Okay. So the first ones, I'm looking for an angle from 0 to pi that gives me root 3 over 2. Okay. So that would just be, you think about your reference angles, that has to be pi over 6. Right? Okay. Number 9, we have cosine inverse of negative root 2 over 2. Okay. In between 0 and 2 pi, there's 2 answers to this, right? There's going to be one in the second quadrant and one then in the third quadrant. But because cosine's inverse output is in between 0 to pi, we want the answer that's in the second quadrant. Okay. And the reference angle will be pi over 4. So to get this angle, it's 1 pi, 2 pi, 3 pi over 4. Okay. Okay. There's also these problems where you're doing something like the sine of cosine inverse of something. For these, you need to kind of do the inside first and then do the outside. And I recommend that all the time. If you have something like sine inverse of, I don't know, 1/2, you know. Evaluate the sine inverse of 1/2 first. Okay, so sine inverse of 1/2 would be pi over 6, and then evaluate sine of pi over 6, which would be, of course, 1/2. Some people like to just jump here, but it could be you could get screwed up if you had to do sine of sine inverse of, say, well, the other way around, right? So if you had sine inverse of sine of, let's say, sorry, I got to find one that's not. So 5 pi over 6. Okay. the answer is not 5 pi over 6. You can't just do that jumping game like they cancel each other out. It's because sine inverse has a restricted output. So what you need to do is first figure out sine of 5 pi over 6. So the reference angle is pi over 6. 5 pi over 6. That would be 1/2. Sine is positive there, so it's sine inverse of 1/2. And of course, sine inverse of 1/2 is pi over 6. Okay, so it's a little bit dangerous, and so what I recommend is always doing like this two-step process, even though sometimes you just get an obvious answer. Okay, so anyways, getting back to here, cosine inverse of root 2 over 2. So I think about where cosine inverse is. Okay, cosine is from 0 to pi. Okay. So I need an angle in between 0 and pi that gives me root 2 over 2 when I put it in the cosine. So that would just be pi over 4. And then sine of pi over 4 would be root 2 over 2. Let's look at another one. So 55. We have secant of sine inverse of negative 1/4. This one's a little bit harder, right? So sine inverse, first let's sort of draw where that lives. Negative 1/4, and you think of this as a triangle, right? So it's, what is it? It's the opposite over hypotenuse. So if I have a triangle in that, and it has to be in this quadrant because it's negative, it has to be in that fourth quadrant. It can't be in the third quadrant because it's inverse sine, and inverse sine is only in this first and fourth quadrant. So anyways, the sides of that right triangle, sine inverse is opposite. So this side here is going to be negative 1 because I'm going downwards from the in the y direction, and then the hypotenuse is 4. Okay. To figure out secant, because it's 1 over cosine, I actually need to know this third side. So I'd have to do kind of a Pythagorean theorem on it. So the hypotenuse squared is 16. On the other side, I have negative 1 squared is 1 plus this, I'll just call it b. Solve for b squared. So b is root 15. And so secant then is hypotenuse over adjacent. So it's going to be 4 all over root 15 at the end of the day. Okay. Okay, so you can always kind of draw a triangle if you want. So for here, you can put a triangle in this first quadrant because this input value is positive. So you would have adjacent over hypotenuse, and then you could solve for the third side, this side, what's called b, using Pythagorean theorem. So it's 4 equals square root 2 squared is 2 plus b squared, and so b squared will equal 2, and so b will equal root 2. And then the sine of this angle is opposite over hypotenuse, so it would be root 2 all over 2, which is the answer I got anyways. Okay, so there's multiple ways kind of to accomplish these feats. But I should be seeing some sort of work, right? If you just write the answer, you're going to be in trouble again. So please do not just write the answer. You got to show me this work. You got to show me you understand how things operate. We're not giving degrees to people just because they know how to work a calculator. Okay, all right. Let's move on to then. So 4.7, the types of questions. I guess I didn't give you a question pool. 4.7, you're looking at problems 1 to 17, and then 47 to 61. Okay. Okay. 4.8 then, we have applications of trigonometry. So I kind of keep it small, 41 to 49. There's some of those helicopter problems. There's the balloon problem. Let's look at a balloon problem. So 49 on page 639. So they kind of give you a picture of this balloon rising in the sky. And then they give you some information associated with it. So we have a right triangle here. They give you some angles. This is 19.2 degrees. And then this angle is 31.7 degrees. And then this length is 125. So there's some observer maybe standing right here. and then there's a hot air balloon rising all the way up to here. Okay, and they want to know how far does the balloon rise, and going from there to there. Okay. Okay, so what you want to do is kind of decompose that value. You want to say, and you're kind of working with similar triangles. There's actually two triangles here, right? There's this one, and then there's this. They're not similar triangles, but they're one's embedded in the other. Okay, so you're going to be able to use your tan formula and make a relationship with this length. And then also, again, with the other angle, the 19.2 degrees, you're going to be able to make a relationship with this length. And then if you notice the relationship between a, b, and x, well, x is just basically a minus b. All right, so I need sort of an equation that relates a and an equation that relates b. So the equation for a, I can use the tan of 31.7 is equal to opposite length, which is a, I don't know, all over the adjacent length, which is 125. And then I could solve for a. A is equal to 125 tan of 31.7. Okay. And then I could do the same thing with this other angle. So the tan of 19.2 degrees is equal to opposite, which is b, all over adjacent, which is 125. And again, solve for b. That will be 125 tan of 19.2. Okay. So x is actually equal to then 125 tan of 31.7 minus 125 tan of 19.2. Make sure you're in degrees. And if you look at the problem, the units for distance are feet. Okay. So this ends up being to the nearest tenth, 33.7 feet. Okay. So I'll probably throw at you a balloon or a helicopter problem. Make sure you look at those. Okay, so that's chapter 4. I think it seems like the majority of the material is in chapter 4. We'll skip around a little bit once we get to chapter 6. I'm not going to put everything from chapter 6 on the test. Anyways, in the meantime, let's look at chapter 5. Okay, so here's 5.1. We're proving identities. So I'll limit identity proving to this 5.1 section. And I'm looking at questions like 1 to 37 odd. So let's look at a couple. So 15, prove the identity, right? You got to go left side, then right side. And you need to write it out like I write it out. Okay, so starting on the more complicated side, you have to write that out. Starting on what side? So I'm starting on the right. I notice. Then you recopy the right side just to verify, so I know you know your left from your right. And then we can use a little bit of trig identities. I'm not going to put any crazy identities in there, mainly just Pythagorean, quotient, reciprocal identities. Basically all you really need. This is sine squared plus. So cotan, I could rewrite that as cosine squared all over sine squared. And then if you distribute, you get sine squared theta. And then the second distribution, the sine squareds cancel, right? So you just end up with plus cosine squared theta. And then, of course, that's just equal to 1 from the Pythagorean identities, which is the left side, which is what we wanted to show. Okay. All right, let's look at one more that's a little more harder. So 31. I may have already done this one, but hopefully it'll ring some bells in your brain. Ooh, I need to study that, or ooh, I know everything already. So there's 2 secant x. Okay, so there's multiple tricks for proving these identities. One particular trick that we learned is just finding a common denominator. So starting on the, in this case, where are we starting? On the the left side, right? Starting on the left, I note, and then you recopy the left side. Okay, and the first thing I'm going to do is just find a common denominator. So in that first fraction, I'm going to multiply top and bottom by cosine. And the second fraction, I got to multiply top and bottom by 1 minus sine. Okay, then I'll have cosine times cosine is cosine squared, all over 1 minus sine x times cosine x. And then plus, I have to FOIL the 1 minus sine times 1 minus sine. So first is 1 on the outer, minus sine x, the inner, minus sine x, so minus 2 sine x. And then the last, plus sine squared x. And that'll be all over cosine x times 1 minus sine x. So now I can combine the numerators over the common denominator. I'll have cosine squared x. Let me rewrite the second numerator so we can clearly see one of the identities. Okay. All over 1 minus sine x, the common denominator. Right. Okay, cosine squared plus sine squared is 1. So we're going to get 1 plus 1. Well, let's just write 2, right? 2 minus 2 sine x over 1 minus sine x times cosine x. Factor out the 2. 2 times 1 minus sine x. And we got a nice cancellation. 2 over cosine x. And we're trying to end at 2 secant, and that's what we got there. 1 over cosine is just the same as secant, which is the right side. And that's what I want to show. Okay. Okay, so expect some identity proving. I sort of just leave the identity work to this first section, and then the rest is more computational in nature. So let's look at 5.2, where I'm having you apply the formulas for the couscous formula and the sine, cosine formula, same sine formula. And I'm looking at problems like 57 to 63. Okay, so 61. They give you, it's like a puzzle question. They give you information, and you have to find some things. So first off, they tell you cosine alpha is 8 over 17, and alpha is in quadrant 4. Then they tell you the sine of beta is equal to negative 1/2, and beta is in quadrant 3. Okay. We're trying to figure out 3 things: cosine of alpha plus beta, and then sine of alpha plus beta, and then tan of alpha plus beta, but that's just the ratio of A and B. That should be easy. Okay, so for the first 2 formulas, because it's the couscous formula, you need cosine alpha, which we already have, but then you need also cosine beta, right? And then we'll need sine of alpha, and then also sine of beta. So I needed to figure out these other functions of alpha and beta. So what you do is kind of draw pictures. So cosine of alpha, alpha is in the 4th quadrant. Okay, so it has draw a triangle in the 4th quadrant, and it's adjacent over hypotenuse, and then use Pythagorean theorem to get the 3rd side. So it's plus or minus, and in this case, because it's going down in the y direction, it'll be a negative. So b will be negative something, negative 15. Okay. And then for the other one, the angle is in the triangle will be in quadrant 3. So again, this time I use sine of beta is negative 1/2, so negative 1 over 2, so opposite over hypotenuse, and then use Pythagorean theorem. to get the third side. And this time it's negative as well, because I'm going the left direction on the x-axis. So this will be negative √3. And that information will tell me what is the other stuff I need. So I need cosine of beta. Cosine of beta is going to be adjacent over hypotenuse, so 8 over 17. Oh, sorry. This one's alpha, and the other guy's beta. Sorry. Somebody knew that. I need sine of beta. Okay, so sine of beta is going to be opposite over hypotenuse, and then cosine of sine of alpha. Jeez, falling apart. I need cosine of beta, which will be adjacent negative √3 all over hypotenuse, which is 2. Okay, and then we just kind of fill in the blanks. So cosine of alpha is 8/17. Cosine of beta, negative √3 over 2, minus sine of alpha, negative 15/17, times sine of beta, negative 1/2, which will be negative 8√3 over 34. They both are over 34, so you can kind of write it like this. Minus 15 over 34. Okay. Then sine of alpha plus beta, the same sine formula, which is on the formula sheet if you need it. So sine of alpha cosine beta plus sine of beta cosine alpha. So in this case, sine of alpha, negative 15/17 times cosine of beta, negative √3 over 2, plus sine of beta, negative 1/2, and then cosine of alpha, 8 over 17. So that'll be, running out of room here. That'll be, again, they have a common denominator. It'll be 15√3 minus 8 over 34. And then for tangent, you just take the ratio of those two. And the 34s will cancel out, but it will be 15 sine's numerator over cosine's all over cosine's numerator, which is negative 8√3 minus 15. If you want to, you can factor out the negative from the denominator, which is what they do in the book. And you'll have this. But this answer is fine. Okay, let's look at 5.3. 5.3, we had the sine 2 theta equals 2 sine cosine formula. Also a bunch of formulas that are on the formula sheet that are provided. 5.3, 7 problems like 7 to 13. And these are kind of quiz questions, again, kind of a puzzle questions that I think of them. Anyways, they tell you cosine of theta is 24/25. Theta is in the fourth quadrant. And then they want you to figure out sine of 2 theta, cosine of 2 theta, and then tan of 2 theta. Okay, so to figure out sine of 2 theta, you're going to have to go 2 sine theta, cosine theta, and we don't know what sine of theta is. So I need to draw, again, a little triangle type deal in the fourth quadrant. Okay. So cosine is adjacent over hypotenuse, and then use Pythagorean Theorem to get the third side. So it's going to be, if this is b, it will be 25 squared equals 24 squared plus b squared. So b will be the square root of 25 squared minus 24 squared, which is, and it's plus or minus, because if b will have to be negative in this case, so negative 7. Okay. So in other words, the sine of theta is opposite, negative 7 over hypotenuse. Okay, So once we know that, we can figure these answers. So this would be 2 times sine of theta times cosine of theta. And if you multiply that out, oops, 625. Okay. For cosine 2 theta, you go to your formula sheet. Probably lost my formula sheets. Where are you? Formula sheets. Sign in. Blackboard. Courses. 3 weeks later. Trig. Course content. So formula sheet 3. There's extra credit out there, people, if you want it. Actually, it's formula sheet 2, right? I'll leave that one up as well. You could use both of these. Where are you? So cosine 2 theta is cosine squared minus sine squared. That's one we don't have. You have to know this one. This one has to be memorized. This other one, no. And sine squared theta. So what is this going to be? It'll be 24 25th squared minus negative 7 over 25th squared. And if you put that in your calculator, you'll get 527 over 625. And for tan, you can just take the ratio of sine and cosine. So you get negative 336 over 527, and you're done. Okay. All right, good stuff. 5.4, you see the product, the sum, some of the product formulas. I'm not too crazy about this section, but problems like 1 to 7 turn out to be important later on. So let's take a look at number 5. We want to convert this into a sum, sine x, cosine 2x. And those are on our formula sheets. So where are you? Down here. Sine cosine is sine alpha plus beta, sine alpha minus beta with a plus in between and a 1/2 in front. Okay, so 1/2 sine of x plus 2x is 3x. Plus sine of x minus 2x is minus x. And you can't leave a minus x on the inside. You have to use the odd even formulas here. So I got sine of 3x minus sine of x, and then that would be your official answer. So you cannot do that. You can't leave it like this. You have to convert it. Okay. So sine of negative x is equal to negative sine x. Okay, so just one little easy problem from there. 5.5 is on solving equations. Okay, so this is very important. So you get a larger set of problems you have to worry about. The first types are the find all solution types. Okay, so find all solutions. And basically what you're doing is finding kind of the answers in between 0 and 2 pi and then adding in 2 pi n, right? So let's take a look at one. 4 sine theta minus 1 equals 2 sine theta. And all right, so I'm going to isolate the sine on one side so you can subtract 4 to the other side, negative 2 sine theta. Divide both sides by negative 2. You get sine of theta is 1/2. Okay. Okay, so I need all the angles between 0 and 2 pi that give me 1/2. There's 2 angles. So the first one is sitting right here at pi over 6. And then the second one will be sitting right here at 5 pi over 6. And then you just tack on 2 pi n. Easy. Let's move on. These next problems are all answers. You want the solutions in the interval from 0 to 2 pi. Okay. So the first one we look at is one of these multiple angle problems. You have the secant of 3 theta over 2 equals negative 2. Okay, so secant is basically cosine, 1 over cosine. So the reference angle that would give you 2 for that would be pi over 3. Okay. We want the ones that give you negative answers. So it'll be the 2 pi over 3 and then the 4 pi over 3. Okay, so we'll have 3 theta over 2 equals 2 pi over 3. And then 3 theta over 2 equals the 4 pi over 3. And of course, plus 2 pi n. Okay. We want to isolate the theta, so multiply everything by 2/3. So theta will be 4 pi over 9 plus 4 pi n all over 3. Okay. And it's better to get a common denominator here, so you're going to use 4 pi over 9 as your first answer, and then keep on adding in multiples of 4 pi over 3. But to make that easier, I recommend just finding a common denominator right off the bat. So this would be 12 pi n all over 9. Okay, same spiel for this other guy. So theta will be 8 pi all over 9 plus 4 pi n over 9, which will be 12 pi. 4 pi n over 3, which will be 12 pi n over 9 from my above work. Okay. And then I'm looking for all the solutions in between 0 and 2 pi. So I can't go over 2 pi, which is the same as, if you put it in terms of denominator 9, that's 18 pi over 9. Okay, so I can't go over 18 pi over 9. Right, so I start at 4 pi over 9, and then add in a 12 pi over 9. So that would give me 16 pi over 9. And then if you add in another 12 pi, you'll go way too big. You'll get 28 pi over 9, which is bigger than 18 pi over 9s. So you're done with that first set. Okay. Then you move on to the second one. So the first one is 8 pi over 9. And then the next one would be 12 plus that. So 12 plus 8 is 20. You'll have 20 pi over 9, which is bigger than 18 pi over 9, so you're done. Okay. The one on our test in class was horrendous, right? There was like 8 answers. This one turned out to be pretty easy, though. Okay, let's look at one more in here. So 63, 2 cosine squared x plus sine x minus 1 is 0. So first you have to use kind of one of your identities, or Pythagorean identity in particular, and then you're going to kind of turn it into a quadratic equation. Okay, so first I'm going to use the Pythagorean identity to change cosine squared x. So remember the Pythagorean identity. If you subtract sine squared on both sides, you get 1 minus sine squared. Okay. So cosine squared can be turned into 1 minus sine squared. And then I'm going to get everything on one side and set it equal to 0. So what do I have? 2 minus 2 sine. I want the leading term, the sine squared, to be positive. So you just multiply everything by -1 or move it all to the other side. And then it's a quadratic type, right? So you factor it. So I have 2 sine x, over here sine x. I need the bigger guy to be negative. Okay. Then you set each part equal to 0 and solve. And again, it's in the interval from 0 to 2 pi. Okay, so for the first one, jumping the gun there, getting impatient. Okay, the reference angle from 1/2 on sine is pi over 6. I need sine to be negative, so it would be in the third and fourth quadrant. So we're looking at this here is 6 pi over 6, so 7 pi over 6, and then one less than 12 pi over 6. And then solve the other guy. Where is sine equal to 1? That will only happen at pi over 2. So we get 3 answers. Okay, did I give you a list of problems? Yeah, I'm sure I got the list of problems. There's no quiz in the final exam. video here. Just making sure I gave you the problem numbers for all of them. Okay, well, back. Okay, so I'm going to skip chapter 6.1 and 6.2. Not because I don't think it's important, it's just I think we kind of beat that stuff to death. Okay? So I'll skip into 6.3. 6.3 is on polar equations, polar coordinates, polar equations. 6.3, we're looking at questions like 33 to 71. So being able to convert into polar. The conversion formulas are actually on the third formula sheet if you look to the side here. Okay. So anything you need to convert a coordinate is in that little box. Let's look at converting equations. So in particular, first I'll go from rectangular to polar. Okay. So in order to pull that off, I'm just going to replace the x and the y with r cosine and r sine. Just like the formula sheet says. Okay, so I have r cosine theta minus 2 squared plus r sine theta squared will be r squared sine squared theta plus 4. I need to FOIL out that first part. So that's going to end up giving me r squared cosine squared theta minus 2r cosine minus 2r cosine would be minus 4r cosine theta plus 4 plus r squared sine squared theta equals 4. Okay, if I move the 4 over, those are going to just be adding to 0. And then there's a Pythagorean identity here. If I factor out the r squared, I'll have cosine squared plus sine squared. So I'll have r squared times cosine squared plus sine squared. Then minus 4r cosine theta. And on the other side, I'll just have 0. Subtract 4 from both sides. Then this thing is just equal to 1. So I have r squared minus 4r cosine theta. 0. You try to avoid dividing by r because r could be 0. So you just factor it. And the weird thing about this one is you kind of get two answers. R is 0 and r minus 4 cosine theta is 0. In other words, r is 4 cosine theta. So you always want r equals something. Like in the xy formulas, you always want y equals something, ideally. The weird thing is there's two of them. But what they say in the book is this r equals 0 here is kind of redundant. Okay, we don't need it. It's just extra. Because this other formula will have that value in it. Okay, when theta is equal to 0, r will equal 0. So that point will be on the graph. And you don't need that r equals 0 portion. Okay? It wouldn't hurt if you wrote it. You know, I could write both of them, but this is the way it's usually seen. Okay, let's look at one more. And in this one, we go in the other direction. But it's the same kind of problem. Okay, it's the same. You'll end up with the same kind of format. So these are always going to be circles. If it's r equals a cosine theta or r equals a sine theta, they're going to be kind of. So remember, r equals. I don't know how important this will be on the test, but a sine theta will look like this. R equals a cosine theta is this type. Okay. Okay, but anyways, for these problems, I just want you to convert. I don't need you to graph. So let's convert, right? Okay, so I noticed that x squared plus y squared is equal to r squared. That's one of my other conversion formulas on the formula sheet down here, real small. It's from the Pythagorean Theorem. I could replace the r squared then, so I have x squared plus y squared equals 12 squared cosine squared theta. Okay. All right. Well, this doesn't seem to help very much, but let's think about what x and y are in terms of cosines and sines, basically. So x is equal to r cosine theta. Right? And in particular, if you were to substitute in this value for r into here, what do you get? You get x equals 12 cosine theta times cosine theta So x is equal to 12 cosine squared theta. This 12 cosine squared theta is actually sitting sort of right here. If you were to factor it out a little bit, you'll have 12 times 12 cosine squared theta. In other words, it's sitting right here. That's x. Okay. So it's actually right here. And you could, of course, replace that, and that's the goal. Whenever you're going from polar to rectangular, you're replacing the r's and the thetas with x's and y's. So you'll have 12x. Okay, so what is this thing? It's a circle shifted to the left or the right. Let's see which way it's shifted. So if I move the 12x to the other side, I get x squared minus 12x, and then I can complete the square. Equals, and then I have to complete the square on the other side. So negative 12 over 2 is negative 6. 6 squared is 36. So I'll have x minus 6 squared plus y squared equals 36. Okay, if you wanted to, on my test, you could just leave it like this. If I got a question like that, you could just leave it like that. But here it is, and you know, if I had to graph it, which I'm not sure if I'll have you graph it, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The center is at 6, 0. 1, 2, 3, 4, 5, 6, 0. The radius is 6. So it's going to look like this. Okay? Okay, so converting back and forth with equations. 6.4 then is graphing polar curves. So I think on the test I gave you a rose curve. In my notes here I have a snail. So I'll either give you a rose or a snail. Let's see, 6.4, 13 to 27. So let's look at a snail. This is actually the cardioid version, which is cardio like heart. All right, so this thing, the amplitude is 2. It's whatever's in front of cosine in this position. The period and phase shift, there is no phase shift. It's just the period is kind of traditional from 0 to 2 pi, so the period is 2 pi. And then your tick marks will be divide the period by 4, so it'll be pi over 2. And one last thing, there is a vertical shift up too. Okay. So you could either do a table. I like drawing it in the r theta plane. Okay. So what do I have? 1, 2, 3, 4. 2, 3, 4. Cosine. This is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi. Normally it would look like, let's put it in blue, it'll look like this. But we're shifting it up by 2. So each one of those points will be shifted up 1, 2 units. 1, 2 units. 1, 2 units, 1, 2 units, 1, 2 units. Okay, so our new graph would look like this. And then you go to your XY plane and put it all the concentric circles. And your angle lines, if you need them, please use them. Especially if it's like a rose petal, you're going to have to put those angle lines in there. For this one, there's not really any angle lines except on the it's pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2. Okay. Anyways, going from 0 to pi over 2, I'm starting at 4, so I really need to make these 2, and then this is 4. Okay. So I start at 4, and then I drop down the 2. So let me put it in a different color. I'll put it in red. So I start at 4, and then it sort of drops down the 2 at pi over 2. And then from pi over 2 to 2 pi over 2, it's going to decrease to 0. So it'll kind of curl to 0. And then from pi to 3 pi over 2, it's going to increase back to 2 in that sort of sector. So it'll sort of bubble back up to 2. And then in the final sector, it'll increase back to 4. And that'll complete the entire picture of that particular guy. Okay. Okay, so either a snail or a rose petal. The last two sections are on vectors. So first 6.6. Looking at problems like 5 to 51. So you have to know simple things like graphing vectors, adding vectors, finding magnitude, finding unit vectors. Okay, so let's look at number 5. In number 5, they want you to graph it and find the magnitude. Okay. So you can think of this as like an ordered pair, 3, 1. You just graph that point, 1, 2, 3, and then 1, and then draw an arrow to it. Okay, and that will be vector v. The magnitude of that vector is the length of that distance of the arrow. Okay, so the magnitude, and this is just based off the Pythagorean Theorem, will end up being the square root of the 3 squared plus the 1 squared. So 9 plus 1, which is root 10. Okay. 41, they want us to find the unit vector in the direction of the given vector v, which is 3i minus 4j. So to find the unit vector, you need to kind of resize this original vector v, and you resize it by a factor of 1 over the magnitude. So I need to figure out the magnitude. Okay. So you just take the components and square them, so we get 9, plus negative 4 squared is 16. I'll be square root of 25, which is 5. So the unit vector u will be 1/5 times the vector v. Okay. And to multiply by 1/5, you just kind of distribute, so you get 3/5 I minus 4/5 j. Okay. Okay. The last section was kind of introducing one type of multiplication called the dot product, 6.7, and this is the final section, 17 problems like 17 to 37, and then maybe an application like 55 or 57. Okay, so these formulas are on the sheet here. You have to know how to do a dot product, of course, but any other formula you may need is kind of there. Even the unit vector formula is kind of sitting there as well. So you won't need some of this other, obviously these first 3 things we won't need. Anyways, let's look at number 19, where we're trying to find the angle between 2 vectors. Remember, if you take the dot product of 2 vectors and the dot product is equal to 0, the vectors are at a 90-degree angle. But anyways, to find in general the angle, just use that cosine of theta formula. Okay, so in the numerator you got a dot product, v dot w, and what you do is just multiply the components and add them together. So negative 3 times 4 is negative 12, plus 2 times negative 1 is negative 2. And then it's all over the magnitudes of the particular vector. So the first one, square root of 9 plus 4, and the second one, square root of 16 plus negative 1 squared is 1. Okay. Then to find the angle, you just take cosine inverse of that. Okay. And putting that in your calculator, make sure you're in degree mode, 160.3 degrees to the nearest tenth. Then applications. So for finding work, basically you may have some problem where you have a wagon being pulled by a little kid with a force in that direction. So he's pulling the wagon at an angle of 32 degrees. And then they tell you it's kind of the magnitude of the force is 40 pounds. So the magnitude of that force vector is 40 pounds. Then the distance that they move the wagon from here to here is given as 100 feet. Okay. So the kind of the distance from this point P to this point Q, you could say, or the magnitude of this vector PQ is 100. And then you just go to your formula sheet for work. So work is either a dot product of those two, or the product of the magnitude of the force times the distance times cosine theta. So that PQ inside of the double bars really just means a distance. Okay, so force, magnitude of force times distance times cosine of the angle between the two vectors. So let's try that. Work will be 40 times 100 times the cosine of the angle, which is given as 32. Plug and chug, 3392 in the calculator. The units are foots times pounds. So foot-pounds, they will say. Okay. And that's it. So expect, any of those problems are fair game. Expect something a little less, with fewer problems than what I did here. I'm thinking around 25 problems. So I won't be putting everything on the test, but anything I did in the lecture here is fair game. I'm trying to organize myself before I get carried away here. Okay, yeah, so the formula sheet 2 and formula sheet 3 are fair game. You're allowed to use those so have those printed out or copied down on a piece of paper and be ready to show me that on the day of the test, on the day of the final, excuse me. And okay, so I'll let you go with that, and hopefully we'll see you again. All right.